Welcome back, guys. Now let's just take a look at the word probability. And since we're dealing with the word with probability, actually, let's just take a look at also at the word probability. They say how many different arrangement of the letters of this word are possible. In other words, they're saying how many different words that can be able to be formed by the word probability. So to get the number of words that can be able to be formed by the word probability is just that we say number of words is going to be equal to what? We count how many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which is 11 factorial divided by the number of letters that they repeat. How many letters that they repeat here? We have B, and we also have I, and that's all. We're just going to divide by 2 factorial multiplied by 2 factorial. And then if you work this out, you're going to get a quite big number, which is 9979200. So this is the number you're going to get. So this is the number of ways that can be able to be formed by the word probability, So the second example is one of my favorite. They say if the letters of this word are arranged randomly, calculate the probability that the resulting word will start and end with B. So since by now I hope you know that probability is equal to what? Is equal to the total number of something, is an event or something that meet the condition, divided by the total number that has the total number of something that without a condition, and that does not have a condition. That's how I define probability, and that's what it is actually. So first, the one that does not have a condition, we already find the number of ways that are there without a condition, which is we'll get this number. So we have to get the number of words that follows the condition. So what is the condition? The condition, they say that the letter it must start and end with B. So we've been doing this on our previous videos, guys. That when we have a letter that they have to start and end, what do we do? Now we have 11, 1, 11. So what do we do when we have something like this? Is that this words is fixed, So we're going to have one option, and then also you are going to have one option. I know you might be saying we have two options because we have two B's here. No, mathematically, guys, these two letters are different. This one can be B1 and this one can be B2. So in other words, B1 is fixed here. There's only one B1. That's why we have one options, Or B2 here is fixed. That's why we have one option, So we have one options, either of those kind of stuff. So hence we write one. Hence we write one options there. We don't have two. So how many letters are left there if we, two of them are used? We are going to have 11 minus 2 is what? Is 9 actually. And then we're going to have 9, 8, 7, 6, 5, 4, 3, 2, 1. This is quite a long way actually. So I'm going to just write 1 multiplied by 9 factorial multiplied by 1. But remember, there's still some words that repeat there. There's still some words that repeat, guys. So I want you to pay close attention. There's still some words that repeat. So when there's still some words that repeat, the one that was fixed, we don't count it. The one that was fixed, we don't count it there. So how many are there that repeats? We only have this one. This one is already fixed, so only have 2 factorial. So if we work this one out, we are going to get a number of 1, 8. It's a quite big number, 1440. So this is the number of words that can be able to be formed if the letter must start with B and end with B, So but they want the probability of that, So the probability is going to be equals to 1814440. Remember, this is the event that meet the condition, and then divide by the total of the total number of words that does not have any condition, which is this one, which is 9979200. And then if you work this out, you're going to get 1/45 as your probability. So this is the probability that the words can start with B and end with B. So that's it for this video. See you on my next video. Sharp.